Kingside.com. All right, let's do a lesson on arrays and how arrays work in PHP. An array is an ordered collection of items or elements. When you need 2 or 3 variables, no array is needed. But what if you need 200 or 300 variables? Yes, you need an array for 200 or 300 variables. I often think of arrays as declaring mass quantities of variables. When I need lots and lots of variables, I use an array. You can access the collection as a whole by using just the variable name, or you can access the individual elements using these square brackets that you can see here in the code. This is a declaration of the array called the money. In PHP, it's pretty obvious when I'm creating an array because we use the keyword array. I don't know about you, but that's pretty clear to me that the money is an array. If you look at the red underline, I'm assigning an array to the variable. The other way you can tell you're using an array is by the presence of the square brackets. When you see the square brackets like on the lines below, read that as an array. So this ends up being an array of float numbers called the money. Beginners most often confuse the arrays because they start with an index or subscript of 0. The first position of an array is always at position 0. Now I'm going to show you a little picture of how this array is created, and the numbers here indicate the position within the array. Pay attention to position 0. It's very important to understand how it works. We'll start by assigning initial values to it. You don't have to, but I've chosen the option here of filling this array with data when I originally create it. So the array creates this block of data down below here, and then each of the items listed above is going to be assigned to a subsequent position in the array. Remember, they start at position 0. So the first item in the array, the 20.25, is going to go into slot or position 0. The second number in the array, the 19, is going to go into index 1. Got that? First item, position 0. Second item, position 1. The 27.5 is going to go in position 2. The 82 is going to go in position 3 or index 3 or subscript 3. And finally, the last number will go in position 4. So this is an array of 5 numbers occupying subscripts 0 through 4. Let's pull a value out of the array. Again, an array basically is a collection of 5 variables. This array is anyway. What I'm going to do is go to the money, square bracket, 0, and the square brackets. That number you see inside the square bracket, the 0, is called the index or the subscript or the slot number. It says go to position 0, which is the first number in the array, and let's take that data out of there. Now I drew a red line down below, so position 0, the 20.25, is going to be taken from the array and moved over to the variable player money. And that's what that line of code does. Access position 0 of the array and pull it into the player money variable. And we can move the opposite direction. We can take it from a variable and move it back into the array. So we're going to insert a value into array subscript 3. This would be the 4th number in the array. So I go to the money, array slot 3, and assign it player money. Once again, the arrow is showing you the direction that the data is moving. I'm pulling it out of this variable and overriding what was in position 3 before. Well, what was in position 3 before? It was this 82. I initially set up subscript 3 to have an 82, but since I overwrote position 3, the 82 has disappeared and overwritten with what was in player money. Data can move into and out of an array. So the thing I want to stress most is basically this is an array of 5 float variables. And I use them just like I use any other float variable. Player money is a float variable. I can take something out of the array and put it into player money. I can take it out of player money and put it back into the array. Using an array variable is no different than using any other variable, except you've got to use the subscript. You've got to tell it which index or slot number of the variable that you want to access. And we can do some math on it. Let's go ahead and pull the number out of the money position 4. Now again, the arrow is showing you where I'm grabbing this data from. In position 4 or index 4 is a 4.75. I'm going to pull that 4.75 out. I'm going to add this literal 5.50 to it and get a 1025. What am I going to do with the 1025? I'm going to assign it back into position 4 of the array. So after doing the calculation, 10.25 is assigned into array slot 4. And you can see the 475 that used to be in that position has been replaced by 1025. As you can see, array assignments are destructive. When I put something new in position 4 of the array, it overwrites what was in position 4 of the array before. Do one more just to make sure we get the hang of it. I'm going to go to the money position 1 or index 1. I'm going to pull this 19.0 out of the array, and then I'm going to subtract the 12.25 from it and calculate 675. See, I'm keeping track of the player's money in this array, and as they add or subtract from their totals, I want to update the values stored in the array. Remember, this is an array of 5 float variables, and I'm changing the values of the individual variables. The 675 that was calculated is moved into position 1 of the array. There you have it. That's just a simple setup and use of an array. They're not too complicated. All you got to do is remember to think of an array as a collection of multiple variables. And since it's a collection of variables, you have to use the square brackets to indicate which of the multiple variables you want. And most of the confusion happens with beginners in that position 0. The first element of the array is at slot or index 0 of the array. Let's look at declaring arrays and the different ways we can declare the arrays. Basically, I like to think of 3 different ways to declare an array. Number 1, we've already seen in a previous slide. That's where you declare and init the array using the array command. You basically declare the array and fill it with initial values. The second way is declare only, which we'll show you on this slide, and we'll show you another option for declare and init also. And then the third way is declare and fill the array. So create an array with a certain number of slots filled with a value. Different ways to create the array at the beginning. So let's look at declare only. We're going to create an empty array here. I'm going to say hand equals array with open and closed curly brace, nothing in it. In PHP, arrays are not objects. An array with no elements is considered to be an empty array. I've created the hand variable here, but I really haven't allocated any slots for it, and I certainly don't have any data in those slots. This is an empty array, hand. Later on in the code, I can put some stuff in it, and it'll fill out just fine. But as of now, as of the time this line of code executes, we have an empty array. Sometimes that's what you want, but sometimes you want an array with data in it. And here's a new thing. It's PHP 5.4 and above. Be careful if you're running version 5 because there's different flavors of 5 out there. The array command has been sort of upgraded or replaced with just using square brackets. This new syntax, $hand equals square bracket, an initialization list, end of square brackets, is basically a replacement for calling array. Don't need to use it. And in fact, if you're using a lower version of 5, I'd avoid using it. What this does is both declare the array and initialize it. So you can see what it's done here is it's created an array with 5 slots because I gave it 5 values and filled them all with zeros. It's initialized them. When I assign that array to hand, it basically attaches the variable name hand to this array. See the difference? On the first line of code, I created an empty array. But on the second line of code, I created an array, slots, and put actual data into the slots. And it's my option. At the time I'm building or writing the code, if I don't know what I'm going to put in it, I might use the first option. At the time I'm creating the array and I do know what to put in it, I'd use the second option. Either way, this code will work. Doesn't matter which line above it executed beforehand. We can start putting data into the array almost immediately. Remember the square brackets. I want you to read that as array. I read this as hand array index 0 equals 14. So in position 0 of the hand array, I'm going to insert a 14, and you can see this 0 indicated where in the array this data should be inserted, and the red box shows you a 14 showed up at that location. I'm going to go hand at index or subscript 1 and insert a 6. And again, the square brackets are showing you that position 1, the second item in the array, should be set to a 6. Arrays are easy as long as you get used to that square bracket syntax. An array's variable is like any other variables, except you got to use those square brackets. I'm going to say $hand at index 2 should get the value 51. And if 51 gets inserted in position 2 of the array. I can go on forever. I could put something in 3, I can put something in 4, I can put something new in 1. I don't need to show you this 100 different ways. I'm inserting data into the array. And when it comes time to pulling that information out, as long as I remember to use the square brackets to specify which item in the array I want, I can pull the information back out of the array. Another commonly used and very helpful thing to know about an array is how many items are currently in the array. This line of code, length equals count of hand, use the count function to access the length of the array. In this case, it's 5. You can see 2 lines above, I initially created 5 items. Even though I only assigned 3 slots to the array, those 5 items are still there. Count returns the number of slots that have been allocated for the array. In PHP, arrays are very dynamic. I can always add a new slot. I can just go to the hand at slot 6 and put something in slot 6, and all of a sudden this thing will have 7 slots, 0 through 6. So count is a very, very critical function that you've got to learn. It's going to tell you at the time this executes how many array slots are allocated. Count how many slots are in the array. We'll be using count later in this lesson, so you'll see it in use. Now there was a third way. You can declare and size the array. This creates an array with 50 slots, this line of code down here. Array fill is a special function in PHP that says I want to create an array and I want to fill it with data. So if you look closely at array fill, the first parameter, this 0 in the beginning, says what is slot number is the first slot. So there'll be slot 0 would be the first slot of the array. The second number is how many slots we want. The 52 indicates there should be 52 total slots, which means they'll be numbered from 0 to 51. And then the third parameter here is what is the initial value. The -1 says I want 52 slots filled with -1. In this case, the deck becomes an array variable, an array of 52 ints. Their indexed numbers are 0 to 51, and each slot contains the value of -1. I didn't have the room or the space here to draw 51 lines and show 52 slots with -1s in there, but basically it's an array of 52 -1s. That's it. There's several different options when it comes to declaring arrays. You can create empty arrays, create arrays with initial values in them, and you can create arrays that are basically empty, filled with some flag or some number. Or you can create empty arrays, arrays filled with a certain value. Next up, let's look at something called parallel arrays. That's when you have 2 or more arrays with corresponding data in them, where the information in an index or slot corresponds with the same index in another array. So slot 1 in the players array, which contains elk, aligns with slot 1 in the money array, which contains 19. On an online video game that's keeping track of players and the amount of money they currently have, you'd need 2 arrays, one to hold the player's name and one to hold the money. Trace this code and see how it works. First of all, I'll create the players array here and fill it with values: Viper, Elk, Bond, Born, and Powers. 5 items, so they'll be index 0 through 4. And that's just keeping track of the player's name, the player's screen name, the player's handle, whatever you want to call it. Players in this game collect money as the game goes along, so I need to track how much money each player currently has. One way to do that is with a parallel array. So this second array of money, slot 1 of money is going to correspond to slot 1 of players. Slot 3 of money is going to correspond to slot 3 of players. You can see here that Viper in slot 0 has $20.25. Elk in slot 1 has 19. Bond in slot 2 has 27.50. Born has 82 and Powers has 4.75. Each slot in the lower array corresponds to a slot in the upper array. There's my money array next to it, and I drew it so they aligned with each other so we can easily see how parallel arrays work. Let's trace through some code that's going to access some data in the array. I'm going to have the user enter a player number 0 through 4. I have 5 players in there in slot 0 through 4 of the array. So I have them enter which player do you want to access. In this particular example, the input comes in as position 1. I want to access the player in position or slot 1 of the array. So the user has entered slot 1 as their requested player, and I'm going to execute this print statement and I output the word player. Then I'm going to access the players array and access slot 1 of the players array. And elk shows up when I print that out and has $, and I'll access the parallel money array on the same slot. When I access the parallel money array, you'll see that they have 19. See how position 1 in the player array matches position 1 of the money array? That's what we mean by parallel arrays. Let's start over and try it again. Let's ask the user to enter a player number between 0 and 4. And this time, let's have them enter a 4. The player is requesting the data in slot or index 4 of the array. I put a red box around it up here to show it to you what position 4 is. When I go to print out what's in position 4 of the array, out comes the word player. Then I access slot 4 of the players array, and there's my Powers. Has this amount of money, and I access slot 4 of the money array, and there's the 475. That's what we mean by parallel arrays. They're a very easy concept to understand. Anything in position 3 of array A matches the data in position 3 of array B. Let's start over and try one more index. Have the user enter a 0 and then go get the data position 0. So you can see the variable $ slot has the value of 0 in it. That means we want to access slot 0 of the array, or the first item in the array. When I go to output this line of text, I'll go to player slot 0 and you'll see there's a Viper in that. And then I'll go to money slot 0 and you'll see their amount 20.25 shows up. The red boxes is showing you the data in the 2 parallel arrays. There is a hidden danger lurking here. Let's enter one more index and make a mistake this time. For whatever reason, we asked the user enter 0 to 4 and they entered a 5. That's not good. Our arrays are at index 0 to 4 and slot 5 is not good. Slot 5 is off the end of the array and technically at this point does not even exist. Well, if it doesn't exist, I better not access it. So when I go to print this statement and I say go to player slot 5, I'm going to get a big fat error message. This is what we call a runtime error. When you go to an array slot that doesn't exist, you will get an error. You will not get results. So be very, very careful when you're using any arrays, not just parallel arrays, that you keep within the boundaries. If you have a 5-slot array, they are 0 to 4 indexes. If you have a 10-element array, their index is 0 through 9. If you have a 100-element array, the subscripts are between 0 and 99. Keep in bounds. You cannot access a negative array slot. You cannot access an array slot off the end of the array. Very, very important that you're always mindful of the dimensions of the array. What is the first slot? Usually 0. What is the last slot? Usually length minus 1. Now let's look at something we can do with an array. Let's linear search the array. Let's ask to find something in the array and find out where it's located. Linear search is a brute force algorithm that loops through the entire array looking for a value and returning its position in the array. Returns the index or subscript of where the item was found, if it was found. Let's trace the code and see how it works. Let's call the function linear search. We'll pass the first argument $array to this parameter $data. Now there's something new on this line. There's an ampersand in front of it. It says I want to pass a reference to the array. PHP's default is to make a copy of the array as the parameter, and we really don't need a copy. So what we're going to do is pass it by reference so it doesn't make a copy of the array. The second argument, $key, is what we're looking for. I'm going to assign it to the parameter target, and this is what we're looking for inside the array. What I've shown down here in the bottom of the screen is the variables used on this line. The array is right here. It's already been made and contains these values. Slot is the slot number where we're going to find our key if we do find it. And of course there's the key containing 50. We're into the code and executing the code. Target here is a local variable. It's right here. It's going to get a copy of the argument $key. So this is passed by value. So key and target is a copy. Target is a copy of key. Look at how data was handled. Data was handled differently. Because of this ampersand, data was passed by reference. Data is going to point to the same array. It's not going to make a copy of the array. Sometimes when you pass large arrays, it takes a long time to make a copy, and that ampersand prevents the copy from being made. However, it's still the same array, so we're going to search it. We create a variable $I here and initialize it with 0. The first position of the array is slot 0 of the array, so when we want to search an array, we always start at position 0. And we go all the way to the end. We use the count function. Remember, the count function returns how many items are in the array or how many slots there are. So count is going to return a 5, and 0 less than 5 is very much a true statement. As a true statement, the for loop is going to go inside the for loop and execute the code inside the for loop. The target, which is 50, does it match data slot I? And it doesn't. I contains a 0, so we're matching 50 against this 20 here. Since they are not equal, it returns a false. When it's a false, it skips the return. Now be careful here. I didn't put curly braces around it. I didn't quite have the room for the curly braces. But this is the end of the for loop right here. So when we reach the end of the for loop, we automatically loop back up and re-execute it. When we loop back up and re-execute it, I++ says I is going to go to 1. Look in slot 1 for our data. 1 less than 5 is still a true statement, so we will continue the for loop. We're going to go follow this arrow inside the for loop and check to see if we can find a match for target. Target is still 50. Data subscript I is now 1, is 30. 50 doesn't match 30. That is a false statement. As a false statement, it will skip the if, hit the end of the for loop, and come back up and do the for loop again. I++ goes to 2. 2 less than 5 is a true statement. As long as this middle statement here is true, we're going to execute the for loop, and that's what this arrow is showing us. When I is 2, execute the for loop again. Here's something interesting. Our target is still 50, but data subscript I, which is 2, is also 50. Well, 50 equal 50 is a true statement. As a true statement, it's going to execute the statement in the if state. The if block will execute. The return $I executes. What does that do? Well, $I contains a 2. You can see it clearly here in the local variable. Target and $I are local variables, and the local variable says a 2. Let's send that 2 back. Where does the 2 go? Follow the arrow. The 2 goes back to the variable that's being assigned the result of linear search. The 2 is sent back and assigned to $slot. The 2 shows up in $slot, which indicates linear search success. The key 50 was found at slot or index 2 of the array, and I drew a red box around it to show you that 50 was found at position 2. Also notice that my local variables like target and $I went away. So did $data. All the local variables disappear after the function is done running. The global variables like slot and key stick around, but the local variables used in linear search disappear. Let's linear search again, but this time let's linear search for a value not in the array. Key contains a 25 this time, which isn't in the array. Dollar array is still the same thing. A dollar slot I blanked out, but we'll be getting a new value for dollar slot. We'll see that in a little bit. I'll pass dollar array to dollar data by reference so it doesn't make a copy of the array. I'll pass key to target, and target will contain a 25. Target is a copy of the parameter. We're set up just like we are before, and we will run the for loop. We'll start at position 0 of the array because that's the beginning. We'll do 0 less than 5. Count returns the number of items in the array, and we are certainly not past the end of the array at the beginning of it. And since that condition is true, we'll execute the if. The target is 25. Data of slot 0 is a 20. That's not a match. Since it's not a match, we will spin back up in the for loop, execute the I++. 1 less than 5 is a true statement, so we'll test our if again. 25 equal 30. Does everyone see where that 30 is coming from? I contains a 1, so we're looking at position 1 of the array, which is a 30, and 25 does not match that. As a false statement, it spins back up in the loop. I++ goes 2. 2 less than 5 is true. We're back to where we were last time. Does the target 25 match slot 2, which is 50? And the answer to that is false. They are not a match. So we spin back up into the for loop one more time. I++ goes to 3. 3 less than 5 is true. We need to test the if statement again. 25 equal to 10. Remember, I contains a 3, so we're looking at this number right here in the array, and it's not a match. As a false statement, it will spin in the loop again. I will go to 4. 4 less than 5 is still true, so we'll test slot or index 4 of the array. And it doesn't match. Our target is 25. Index 4 contains a 40. Not a match. That's a false statement. So something interesting is going to happen. We'll spin back up in the for loop because we got a false. We'll do an I++ goes to 5, but 5 is off the end of the array. When we ask is $I less than count, it is clearly a false statement. We looked at every number in this array and none of them match. So eventually we'll hit the end of the array and this for loop will exit because of that false statement. When this for loop exits, it will get to this return statement. This return statement returns a -1. It sends back a -1. Now, who gets the -1? Whoever called linear search. In this case, $slot equals gets the -1. $slot gets the -1. And the -1 in that variable is an indication that linear search failed. The key 25 was not found. And the -1 tells the caller, no go. It's not in the array. That's a linear search. Like I said, it's a brute force algorithm. It's not known for being fast. Let's look at another search algorithm. This one's called binary search. I'm not going to trace the code because we really don't need to know the code exactly here, but I want you to understand the concept of binary search. Binary search is a much faster alternative to linear search if your data is sorted. Linear search is slow, binary search is much faster, but it does require a sorted array. In this case, notice how array is in order. 10, 25, 30, 45, 50, 65, 70. This is a sorted or ordered array, and it is a requirement of doing a binary search. Binary search is what we call a divide and conquer algorithm. It works by repeated chopping of the problem in half. A classic divide and conquer. To see how it works, let's run a binary search and just trace it while visualizing the array. I'm going to look for, in $array, the value 50. I've set up some variables over here. Array is right there. Boom. This 50 is going to be assigned to key. That's what I'm searching for. And $slot is my return value. Again, binary search, like linear search, will return which slot it found the data in. Binary search says start at both ends. Search between index 0 and 6. Locate the middle and start your search in the middle. So 0 plus 6 divided by 2 is 3. It's going to start by looking at the 45. This is why the data has to be sorted. If what I'm looking for is bigger than 45, I'll go to the right and search for it on the right. If what I'm looking for is less than 45, I'll go to the left and look for it on the left. In this case, our key or target is greater than that middle item. 50 less than 45 is false. 50 must be to the right. Is that clear? If the data is sorted, bigger numbers are to the right, smaller numbers are left. We're looking for something bigger, we got to go right. What it'll do is it'll reduce the search area. It'll say, well, now let's search between 4 and 6. Let's exclude 3, which we already looked at. Calculate the middle. 4 plus 6 divided by 2 is 5. And let's look at position 5 of the array. In this case, 50 is less than 65 is a true statement. 50 must be to the left of 65. The data is sorted, so anything smaller than 65 has to be the left. But remember, we've already excluded position 3. So by now our index, our position, is just 4. The start of where we're looking for is 4. The end is 4. If I do the math, 4 plus 4 divided by 2 is 4. It says look at position 4. That's where the speed comes from. We already looked at position 3. We don't have to go past it. When we look at position 4, what do we find? We find our data. So 50 matches the 50 in position 4, and we return the 4. And who gets the 4? Whoever called binary search gets the 4. We send the 4 back from binary search. Slot is updated, and you can see a 4 appears in the variable slot. Let's do a new binary search. Let's use a variable instead of a hard-coded value. Again, we tend not to use these hard-coded values. I'll show you one or two because you'll see it in the real world, but we prefer to search for key rather than there. And that way we just alter key and the same call works. A new value 30 appears in the variable key. We'll call binary search and we'll pass the key as the parameter to the binary search. Once again, binary search will start at both ends. It'll say search between 0 and 6. How does it search between 0 and 6? By calculating the middle. 0 plus 6 divided by 2 is 3. So I will really start my search at the middle, or 45. 30 less than 45 is a true statement. As a sorted array, 30 must be to the left of 45. Let's go left and search the left side of the array. We have left is between 0 and 2. We'll calculate the middle of that. 0 plus 2 divided by 2 is 1. And we'll say, okay, let's compare to position 1. Do you see the divide and conquer? We've searched 3. We've searched 1. We've determined that it must be between 1 and 3, which is 2. The start is 2. The end is 2. And the middle is 2. 2 plus 2 divided by 2 is 2. So let's search position 2. And it found it. Our key was 30. We found 30 in the array. Boom. Return index 2. The value 30 was found in position 2 of the array. Return that as the slot. Are you seeing why binary search is faster? It doesn't make a difference when the arrays are really small, but if you're searching a huge array, chopping that data in half greatly speeds up the algorithm. Set up a key of 80. Once again, we'll search for something that isn't in the array and see what happens when we can't find the data. Let's call binary search and say, let's search this entire array. It'll start at both ends and calculate the middle, and it'll end up comparing key to the middle item, which is 45. 80 less than 45 is a false statement, so 80 must be to the right of this sorted array. Readjust the boundaries of my search to 4 and 6. Calculate the middle as 5 and go to the middle and look for my data. 80 less than 65 is a false statement, so 80 must be to the right. Calculate the new parameters. I'm going to search between index 6 and index 6, the middle being 6. Ooh, sounds ominous. But I'm going to search position 6 of the array, and it's not going to be good. 80 less than 70 is a false statement, so 80 must be to the right. I need to go to the right of slot 6 to locate an 80. Well, watch carefully. Look at the blue arrow and see what happens. Wham! Did you see the blue arrow cross over the green arrow? When the blue arrow crossed the green arrow, that tells us 80 was not found. That means our search was unsuccessful. And when our search is unsuccessful, what do we return? We send back a -1. -1 gets sent back to the calling binary search, and it indicates that I searched for 80 in this array and it was not found. Binary search eliminates half the remaining items when doing a comparison. That's why it's much faster than linear search, which only eliminates one item. The only drawback, though, is binary search data has to be sorted.